Assalamualaikum warahmatullah, and hello back again students. Okay, so this is the second video of matrices. If you haven't listened to the first one, okay, so I put the link in the description box down below, so please click that one first and then come back to this video, okay, because you have to know about the operations of matrix, okay, and the types of matrix before you can move forward to this video. In this video, we will learn about determinant as well as inverse. So for those who have look or listen to the first video, okay, you may proceed. So let's look into the determinant of matrices. Determinant occur through mathematics. If the matrix A is a square matrix, then determinant A is written as bracket A. Okay, so the bracket is only a line. Okay. So the properties of determinant for a square matrix A, okay, the determinant A is equals to the determinant of the A transpose. Okay. For square matrices A and B of the same order, okay, the determinant of the multiplication A and B is equals to determinant A multiply with determinant B. Okay, so if you can see the sign as this one and this one. So we will look into determinant 2 times 2 and 3 times 3. Okay, as I said before, determinant must be for the square matrix. Okay. So determinant of matrices 2 times 2 is AD minus BC. If you have A, B, C, D, your matrix A is in terms of A, B, C, D, then determinant of A, okay, you can write that A as this one or use the line, okay, and then your determinant is AD minus BC. The green one minus the red one, okay. Okay, let's look into example. Given the matrices A, B, C, find its determinant if exists. So this is the answer for the previous example. Okay, the value of each determinant A, B, and C. Okay, you can do it first. Okay, and remember it is A, D minus B, C. Okay, so for A we have negative 17, for B we have negative 7, and for C we have 6. And then question B asks us to show that the determinant of A is equals to the transpose, the determinant of the transpose. Okay, so we transpose A first. A just now is 4, 3, 7, 1. So when we transpose, okay, the column will become row 4, 7, and then the next column 3, 1 will become the second row, which is 3, 1. Okay, so again the determinant is the same. Okay, A, D minus BC. Now we have 4, 1 minus 7 times 3 equals to negative 70 itself. Okay, so we have shown that the determinants is the same, equal. And then for B2, the question asks us to show this one. Okay, so again you proceed as the question asks, means multiplication first. You do multiplication of A, B. So you multiply A, B. Okay, remember how to do multiplication. For the first matrix, you only consider the row. For the second matrix, you only consider the column. Okay, so this 19 is actually 4 times 1 plus 5 times 3. Okay, 4 times 1 plus 5 times 3. Okay, let's look into another one. For example, this 17. Okay, this 17 is actually 7 times 7, 1 here, the second row with the second column. Okay, so 7 times 2 plus 1 times 3. So 7 times 2 plus 1 times 3, then you get 17. Okay, so after you do the multiplication, you find its determinant, okay, which is 19 times 17 minus with 17 times 12. Okay, so you get 119. And then how you do this one? The determinant A times with determinant B, you actually only take from your first answer. So determinant A, you get negative 17. Determinant B, you have negative 7. So negative 17 times with negative 7, then we'll have negative 19. And you have shown that the determinant of this one is equal. Okay, now let's look into determinant of 3 times 3 matrices. Okay, there are two methods to determine the determinant of 3 times 3 matrices. Okay, the method 1, what we call diagonal expansion method. Method 2 is what we call minor and cofactor. Okay, let's look into the method 1, the diagonal expansion method. If your matrix A 3 times 3, okay, as shown, the determinant of the matrix are obtained by adding 2 more columns on the right with its first 2 columns. Therefore, we have 3 times 5 matrix. The determinant A is given by, okay, this formula. Okay, how do you come with this formula? So actually, okay, as you can see here, it added 2 more columns. This is the column number 4, this is the column number 5. Where do you get this column number 4 and number 5? It is actually the same column as number 2 and number 1 and number 2. Okay, you add another 2 columns, okay, just using the same element as in your column 1 and column 2. Okay, leave column 3. And then you do the addition and subtraction. Okay, if you see here, the black one here is the one that you have to add. Okay, you multiply all these terms first and then you add all these 3. Okay, so you see here you have A11 times with A22 times with A33 plus, okay, another black line which is A12 times with A23 times with A31, and then you plus again with the third black line which is A13, A21 and A32. Okay, and then you have to minus, subtract with the red line. Okay, red line here, the first red line, the second red line here, the third red line here. Okay, so if you can see here, the red line is A12 times with A21 times with A33, and then you subtract. Okay, and then minus again the second red line which is A11, A23, A32, and then minus again the third red line which is A13, A22 and A31. Okay, so when you do the addition and subtraction, that will be your answer for determinant. Okay, let us do this example. Given the matrices A, okay, so the example have shown the matrices A. I will show you a matrices B and you will do matrices C by yourself. Okay, so given the example A, you have negative 1, 2, 3 in the first row, 5, 4, 6 in the second row, and 7, 8, 9 in the third row. Okay, so find the determinant of matrices. Okay, we use the diagonal expansion method. Okay, first we add another 2 columns, which is column 4, the element exactly the same as in column 1, and then you add another column, which is column 5, and the element is exactly the same as in your column 2. Okay, and after adding these two column, okay, you do the addition and subtraction based on your black line and the element in your red line. Okay, okay, let us now solve the matrices B. We find the determinant of matrices B. Okay, the first step, remember, you have to add another two column. Okay, so column number 4 is exactly as the element is exactly as in your column number 1, which is 3 0 0, and column number 5 is 1 2 0. Okay, now we do the addition and subtraction. Okay, so this one you add, okay, and then the red one you subtract. Okay, you take the diagonal of each element. Okay, okay, so the first black line I have 3 times 2 times negative 3, plus the second black line is I have 1 times 8 times 0, and then the third black line I have 5 times 0 times 0. Okay, and then I minus with the first red line, which is 1 times 0 times negative 3, minus again with my second red line, which is 3 times 8 times 0, and then minus again with my third red line, which is 5 times 2 times 0. Okay, there's this 0 here because it's times 0, so everything times 0 will become 0. So if you have a times 0, it will become 0. So 500 here also 0, this one also 0, this one becomes 0, and then this one becomes 0. What's left is only the first one, which is you have 6 times negative 3, and then it becomes negative 18. So this is the answer for your determinant B. Okay, you may do the C, and the answer for C is determinant C equals to 42. So in this second method, we will look into the minor and cofactor method on how to find the determinant of 3 times 3 matrix. Again, so if your A is 3 times 3 matrix, the determinant of the matrix are obtained by, okay, you have that formula. Okay, it looks scary right now, but then as you do the example, you will find it easier. Okay, where the Cij is the cofactor matrix. The cofactor is defined as Cij equals to negative 1i plus j mij. The m is the minor. Therefore, the names you have a minor and cofactor, which is the m and the c. The minor mij is the determinant of the matrix obtained by eliminating the ith row and the jth column. Okay, given matrix A, you have in the first row 2, negative 2, 0. In the second row, negative 1, 5, 1. And then in the third row, 3, 4, 5. Evaluate the minor and cofactors of the matrix associated with the first row. Okay, associated with the first row means your first row is here. Okay, minor and cofactor at the first row is M11, M12, M13. And the cofactor is C11, C12, C13. Okay, how do you find a minor? So actually, a minor M11, if you want to find M11, it is actually, so if you have A, B, C, it is actually when you cancel out, okay, you omit your first row and first column. This is row, first row, this is column. Okay, and then remember this is your row 1 or first row, this is your column 1 or okay, your first column. Okay, when you eliminate that one, what's left is only the EFHI. So you find the determinant of this 2 times 2, which is as AD minus BC. Okay, AD minus BC, the one that you have learned before. Okay, so look at this example. M11 is when I eliminate all these 2, negative 2, 0, and the column 1, which is 2, negative 1, 3. What's left is 5, 1, 5, 1 and 4, 5, which is this one, 5, 1, 4, 5. Okay, and then I do the AD minus BC. AD is 5, 5 minus 4 times 1. Then I have 21. So M12 is when I eliminate my first row with my second column. This is M12. M12 is row 1 and column 2. Okay, what's left is negative 1, 3 here. So you have negative 1, 3 here, and 1, 5 here. So you have 1, 5 here. So you do again AD minus BC for this one, then you'll get negative 8. Okay, lastly, the M13 is when you eliminate the row 1 with the column 3. Row 1, column 3. So what's left is 1, negative 1, 5, and 3, 4, which is this one, negative 1, 5, and 3, 4. Okay, so you do the again AD minus BC for this 2 times 2 matrix, and you'll get negative 19. So this is how you find your minor. Okay, you omit or eliminate the associated row with the associated column. Okay, for C11, C12, and C13, so for C, you don't have to remember the formula. There's an easy way actually. So you remember this part, which is this is positive, negative, positive, negative, positive, negative, positive, negative, positive. This is for the cofactor sign. Okay, so actually the cofactor is the value the same as your minor, with the sign become positive or negative depends on as I show this one, which your element situated. For example, the M11 is row 1 column 1. Row 1 column 1 is positive. Okay, so 21 will become 21 again. Okay, M12 is the green one. Green one here, negative. Okay, so your negative 8 will become 8. Okay, because negative 8 is positive 8. Okay, and then M13, okay, M13 is again positive. So whatever the value of your M, if it's negative 19, then it will be negative 19 as well. So this is actually negative 19, not 19, negative 19, because your sign, the cofactor sign here is positive. So whatever value of minor will be the value of your cofactor. Okay, so for the determinant, okay, as in the formula, you only multiply your element with your cofactor, the associated element in the row and column with the cofactor that you'll find in your row and column. Okay, so for example, C11 associated with element A11, which is the the 2. Okay, so 2 times 21, okay, and then A12 is negative 2, so negative 2 times 8. And then A13 is 0, so 0 times, actually this is negative 19, but it doesn't matter. Okay, the answer will still be the same because times 0 it will become 0. Okay, so what you have is 42 plus negative 16 here. Okay, 42 minus 16, then you will get 26. Okay, so this is how you determine your determinant for 3 times 3 matrices using minor and cofactor method. Okay, so this is the next example. Again, it asks you to find determinant of matrices by using minor and cofactor method. Okay, let's say we choose to expand by the third row. So actually, you can use any rows to do this minor and cofactor. For the example just now, expand by the first row. And then this example, expand by the third row. So third row is 7, 8, and 9. Okay, that's why you have 7 here, 8 here, and 9 here. Okay. So what this is the A11, sorry, this is A31 because we expand by the third row. So this is your A32, and then this is your A33. Okay, so again remember, for the cofactor we have plus minus plus minus plus minus plus minus plus. Okay, therefore in the third row we have plus here, sorry, I will use the red one, plus here, minus here, and then plus here, because it plus minus plus. This is the for the cofactor sign. Okay, so this is the easiest way to do it. You don't have to do the step by step as just now. Means you find M11 first, sorry, M31 first, M32 first, or M33. You can do it directly like this one. Okay, so where do you get the 2, 3, 5, 6? Again, the 2, 3, 5, 6 is when you eliminate the third row with the first column. The third row with the first column. Okay, because this is 3, 1, right? Okay, when you eliminate the third row with the first column, then you have 2, 3, 5, 6. Okay, and then the negative 1, 3, 4, 6 is when you eliminate the third row with the second column. Third row with your second column, then you have negative 1, 3, 4, and 6. And lastly, you have this negative 1, 2, 4, and 5 when you eliminate your third row with your third column. Third row with your third column, then you have negative 1, 2, 4, 5. So next you just do the multiplication and do the determinant of 2 times 2, which is this one is AD minus BC. AD minus BC. So your AD here is 2 times 6 minus 3 times 5 for this matrix. Okay, the second one, negative 18 here, is when you do the determinant of negative 1 times 6 minus with 3 times 4 for the second matrix. And then the third one is negative 1 times 5 minus with 4 times 2 for the third matrix, AD minus BC. And then you will get your answer equals to 6. Okay, I will do B later and you have to do C. Okay, I'll give you answer for C. Okay. Okay, so this is the answer for B. Okay, I've did B. The answer for B is negative 18. So I've shown here that you expand by any rows, you will get the same answer, which is negative 18. So the first one, I expand by the third row. Okay, I expand by the third row. Why I choose the third row? Because the element in the third row, it has 0, 0, negative 3. Okay, it is easier if I choose third row here. Okay, because there's a element 0, 2 zeros. Okay, so whenever whatever times 0 will be 0, so this part will be exactly 0, this part will be exactly 0. So what's left is only my third part. Okay, so remember the cofactors. The sign for cofactor for the third row is plus minus plus. Okay, so plus minus plus here. So what's left is negative 18. Okay, the AD minus BC. Okay, the AD minus BC 6 here is actually 3 times 2 minus 1 times 0. AD minus BC. Okay, I also expand by the first row. Okay, by the first row, then I have 3, 1, 5. So 3, 1, 5 here. And then the sign is positive, negative, positive. So positive, negative, positive. Okay, so you eliminate the associated row and associated column to find the determinant of 2 times 2. Okay, then you have as this one. So again, this is also easy because you have times 0 here, which is will be 0, and another times 0 will be 0. So what's left is only 3 times 16. Okay, the second row. If I expand by the second row, so my second row is 0, 2, 8. Okay, and then the associated sign with second row is negative, positive, negative. Okay, so this 0 will be 0. Okay, this determinant of 2 times 2 have become 0, so times x will be 0. So what's left is 2 times negative 9, which is negative 18 as well. Okay, so you may expand by any rows, not only first or second or third. Okay, you may try using all rows, and you will see that the answer is equal, exactly the same. Okay, so you may do the same method, the minor and cofactor method, to determine the determinant of C, and the answer is 40. So you may expand from any row, but I urge you to do all the 3 rows, and maybe you can do the minor and cofactor method together with the diagonal expansion method. Whatever method you use, the determinant will always be the same. Okay.